Have you ever dreamed of using the same programming language for your client and server-side code in your application, and that language wasn't JavaScript? Let's mash on that.
Hi everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, we're gonna explore the wide, exciting world of Blazor. Wait, what the heck is Blazor, Dave?
Blazor is a super cool project that Microsoft is working on. They're calling it experimental because they're not quite sure where this is going to go yet, but it seems like the project has legs now, and it's something that's, I've been following, and it's worth looking into. So the idea here is that you write like a full stack web application, so that's an entire SPA application, the client-side code and the server-side code, if you have any, in C#. So that's C# running in the browser.
Well, that seems like it's going to be ridiculously slow and inefficient.
You would think so, right? But this is different than, I guess, previous attempts that we've seen at C# in the browser. The thing that immediately comes to mind for a lot of people will be Silverlight, the project that was killed many years ago. But that was a really different thing. That was a browser plugin. It was a lot more like akin to Flash. So
right.
In those there had to be a browser plugin for each browser that was out there. And that's not what this is. The idea with Blazor is that it's actually built on an open web standard called WebAssembly, or WASM for short, which is like a whole new thing for browsers. So if you look at the history of browsers right from the beginning until today, and every different browser that we've worked with, there's really only been one programming language that we could use to target the browser as a platform, and that is JavaScript. JavaScript.
How quickly we forget VBScript.
This is true. This is true. But in terms of a open, cross-browser thing, JavaScript was the only one, and we've seen a lot of improvements on that throughout the years. JavaScript has gotten a lot better, and we have kind of higher level languages, I guess, like TypeScript or CoffeeScript that then compile down to JavaScript that will work on all browsers, bringing us some interesting language features. But it's still really just, it's JavaScript that we were stuck with. And the idea with WebAssembly is that it's more like it's more of a lower level bytecode kind of language. I guess I think of it a little bit more like IL. So how we have in .NET we have the intermediary language. Do you think that sounds like a reasonable analogy for people to think of WebAssembly, Simon?
Yeah, I think so. So there is some relationship, although I'm not entirely sure exactly how it works out between like WebAssembly and sn.js.
Yeah, that's kind of it was a precursor to this, is my understanding. Yeah. So the idea with WebAssembly is that it's kind of a lower level language that other languages can compile down to. And as a part of that, you get really good performance. So it's near native level performance. It's almost as good as compiling, C# to target specifically a Windows machine or a Linux machine. You're getting almost that level of performance out of it. And there's a whole bunch of languages already that compile down to this. There's C and C++, and basically everything you could think of that people use to build applications. There's already people building compilers that will compile that down into WebAssembly so that code can run in a browser, which is pretty cool. It kind of opens up the browser as a platform to a whole lot of interesting things that we didn't have access to before. So flipping back to Blazor, the idea here is that they're experimenting with the idea of building a whole application framework where we can write them in C# and it compiles down, or at least runs in the browser using WebAssembly. And I think the best way to show this is to just go through a quick demo and kind of show you the code, show you how that gets sent down to the browser and how it's interpreted by the browser. So to do this, you just need the latest version of Visual Studio 2017, and then you have to install the Blazor language tools, which all the links for that are over on Blazor.net. That's the best source to look for information on this project. But all I'm going to do is a file new project and select ASP.NET Core Web Application. because I have that tooling installed, there's a couple of Blazor templates here. So there's Blazor, and then there's Blazor ASP.NET Core hosted. So this one here is just a client-side only application. There's no real server-side component to it. It's just an app that ships and runs in the browser kind of thing. The ASP.NET Core hosted one, we'll look at that in a future episode, but the idea there is that then we also have an ASP.NET Core based backend that front end talks to. So that's where we're able to share code between the two. But for now, we'll just look at the client-side part of it, the client-side framework that is Blazor. Before we dive into the code, I'm just going to run this so that we can get an idea of what we're looking at. It's not like a terribly interesting application because it's just a file new project template, but it has some behavior in it and looks, modern-ish. It uses the Bootstrap 4 templates. It looks like a web application and feels like a web application. There's a few pages. There's the home page here where they ask you to fill out a survey because they're trying to gather some feedback on this right now. There's a counter that I can click on and it increments that counter. And then there's this fetch data thing that goes and grabs some data from the server. It's just grabbing a JSON file from the server to populate this grid. So not much to it, just a very simple application. It's just, it's still HTML. It's all just standard web things at this point. You'll notice that the URL is changing, but it's not actually navigating to a new page. This is a classic single page application here, so all the routing is done client side. There's just that initial request to get everything, and then the routing and everything is just handled on the client side. So let's take a look at the code just so you see kind of how these pages are implemented, and then we'll look at how that's sent down to the browser. Okay. Now, the application itself, it looks a lot like a Razor Pages application from ASP.NET Core. Very similar layout here. You'll notice that there's a www root with an index HTML and some other assets in here, like the Bootstrap pieces, so Bootstrap and iconic icons are in there, and some CSS for the site, and the simple little index HTML, which is just basically the bootstrapper for the entire application. It's the entry point for the app, what initially the client requests, the browser will.
So this is the same thing you would see for like an Angular app or a React app, same thing, yeah.
The one interesting thing is this script called where the type is Blazor boot here. So we'll come back to that one because that's not actually what gets sent to the client. That's the only thing about this file that gets changed before it gets sent to the client. And it's done at build time, but we'll come back to that. Otherwise, we have a program.cs, which is, just a standard thing that we would expect to see in a C# application. It's a program with a program class with a main method. And in there, it's initializing a service provider, so that's where we can start adding custom services to the dependency injection. We have a dependency injection in here because it's a modern C# framework, and we would just expect to have that. And then initializes the browser renderer, which is a Blazor thing. Other than that, we have some pages, and we have a shared layout. So these are just CS.HTML pages, which is where I was saying that it kind of looks and feels a lot like a Razor Pages application. So under shared, we have our main layout, and under that main layout, I'm just going to stop this and build to see if I can get that's better. Some of these references aren't resolving, even though they obviously did because the app was running. But this is very much preview experimental stuff, so some of the Visual Studio integration isn't quite there yet. But here we have our sidebar, and then the main part of the app where there's this reference to @body, which is where the individual pages get rendered. So it's very similar to a shared layout page that we've been used to in Razor for a long time now. And if we look at individual pages, like that index page, that's where we had the hello world and welcome to your new app, and that link to the survey thing where they're asking for your feedback. And then we have this counter page, which was that one where I was clicking on the buttons and it would increment. So let's look at this a little bit more closely here. There's a few interesting things that are a bit different than Razor, or than classic Razor, server-side Razor that we've been used to. First of all, there's this page directive. I guess that's similar to how Razor Pages works, but that's basically how the routing in this application works.
Mm-hmm.
So the page directive just tells Blazor that this CSHTML represents a page, and it is the one that we render when we encounter the /counter route. And then similarly, the fetch data route that we clicked on, that one has the /fetch data route on it. So that's how the Blazor knows how to interpret that, and that's the link into how client-side routing works. The other thing here, though, that's kind of interesting is that we have a button. That button that we're clicking has an onClick method on it, or event on it, that we can then just bind to a function. And the functions are just defined down here. So we have an @functions directive, and then it's just C# code. So we're just writing C# code there. Now, you might be a little bit, some people are a little bit freaked out initially when they see this because all the code is, all in the same file as the view piece. Maybe you're okay with that, maybe you aren't, but there's ways with this that you can separate that out and have the code in a different file than you have your view definition. But the idea here is just showing that, it is C# code. This button element is a Blazor thing, so it's a Blazor component. It has events on it that you're able to tie into, so that ends up getting rendered as a button in HTML, and Blazor does all the magic that's necessary to link the events back to these C# functions. But basically we're just clicking on that and incrementing a count, and then magically over here, higher up in the Blazor page, all we did was reference @current_count, and that rendered out the current count. So it just knows after it's done, running any event handlers that it needs to refresh any bindings on that page, and it knows to refresh this. So it was just automatically, after I clicked on it, updating that count for me. Mm-hmm. That's really, that's the basics of what's in here for a Blazor application. There's a lot more to it in terms of how we build components, and I think we'll get into that in future episodes as we dive into this a little more, but that's kind of the basics. So what's interesting to me initially looking at this is how that all gets packaged up and shipped down to the browser. And I think the best way to show that is to just take a look at the developer tools in the browser. So I'm just going to hit F12, open up the developer tools here, and I'll just hit refresh so that it goes and grabs everything from the server again. So we'll start right up at the top. So the very first thing it did was grab that index HTML, and if we look at the response that got sent back, remember that script tag?
I do.
It's different, right? It's not it doesn't just say type Blazor boot anymore. What it does now is it first references source as this _framework blazor.js, which is just some JavaScript code that Blazor needs to do. I think it's where a lot of the DOM manipulation code happens for Blazor. And then this is where things get kind of interesting. So we have main equals web application 7.dll. So that's the name of my app, was web application 7. So it's saying the main DLL for this app is web application 7, and the entry point is the program main. So it's telling it how to start up this application. And then there's this references attribute, and it references all of these other assemblies. So it's referencing Asp.NET Core, Blazor.browser.dll, and all these other Blazor assemblies, and then a bunch of other just .NET Core assemblies, basically. So it's just telling it these are all the assemblies that you need to run this app. And that, if we look over at our app, is exactly the same as what we would see if we opened up our dependencies node here and started expanding the nodes of the assemblies that this application depends on.
So it would be basically what you would expect to be in the bin directory of this.
Yeah, exactly. And we'll take a look at that in a second here, or actually let's take a look at that now. If we were to look at, I'm just going to flip over to open this in File Explorer. And if we look at bin debug, that's standard 2, and under the dist folder, this essentially, if you were done building your app and you wanted to push this out to a server somewhere, this is what you would send. So a Blazor application gets compiled down to something that's entirely shippable purely as static assets. There's no server-side interpretation required here. You could put this up on just on any web server that you wanted, or you could even just put it up as static files on blob storage if you wanted to, and it would work because it doesn't require anything on the server side. So that index.html, this is where that script Blazor boot got converted over to this script tag. There's a lot of interesting things that happen with that when you start referencing other components. If you reference other components as NuGet packages, there are other things that end up in here. So that's another thing that we'll look into in a future episode. And then under framework, that's where we have the Blazor bit, the Blazor.js, and under bin we have all the assemblies that are required for that app to run. So there's a couple other things here that are interesting. There's an ASM.js and a WASM folder. So let's take a look at those next. And if we go back to our browser developer tools here, and we'll just walk through all the assets that get loaded. So there's Bootstrap Mint CSS and Site CSS and Blazor.js. So that we already talked about Blazor.js, and the other two are just, styling things that we would expect. But then we see this mono.js and mono.wasm files, which are kind of interesting. So I don't know exactly what's in mono.js, but the mono.wasm is kind of the interesting one, and this is what makes all of this work. This is how .NET can run in the browser, is that the team that builds the mono runtime for .NET compiled that runtime down, or made a version of that runtime that they compile down into WebAssembly and ships as just mono.js and mono.wasm. And they're actually not as big as you would expect. Those files are a lot smaller than I would have expected them to be, because when you think about the .NET framework and the .NET runtime, typically when that ships it's quite large. Even with .NET Core, it's still a fairly significant install size. It's not something that you would normally just expect to download as an asset when you go visit a website. But if we look at this, it's actually only, well, it's 1.7 megabytes, so it's not tiny in terms of asset size, but it's not huge, and they're still working on optimizing this. But when you gzip that, it's down to, it's only 697 megs or kilobytes, I guess, which isn't bad.
Yeah, it's not terrible. Well, I guess we're living in an era where a megabyte for a web page is not unheard of.
If you look at the total for this entire app, even though it's still just a very simple file new project kind of app, 1.8 megs, it's not totally unreasonable, especially considering how early on this is, and there's still a lot of work they can do to optimize this. But
I would think probably a lot of this stuff, if it ended up on a CDN, would be stuff that browsers already had available to them.
A lot of the like MS Core lib and mono.webassembly files, those could all be on a CDN, and yet, yeah, like you said, browsers aren't going to need to download it very often in that case. So it downloads the WebAssembly pieces here and for mono, and then at that point you basically have a .NET runtime that's running in the browser, and then they're able to just download all your DLLs and run your app in the browser, which is really cool.
Yeah, that's crazy.
So there's another way that they're looking, they're kind of experimenting and not sure what the best way to do this is yet. But there's another option rather than shipping a runtime that's built in WebAssembly and then downloading DLLs. The other option is that they could compile your entire application down to WebAssembly, so that then you were just shipping like a single WebAssembly file. That tooling isn't really there yet, and they're, from what they've been saying, that team that's working on that, is that they don't know for sure if that's going to actually offer much better performance. They just don't know yet. There's a lot of experimentation needed on that. It definitely would take a lot longer to compile your application, so it's probably not the way you would want to do it in just your regular development cycles. That might be more of like a production build You see that a lot in JavaScript frameworks today. You have your development builds, which are quite fast, and then you have your production builds that do minification and tree shaking and all these things that end up being really slow.
Yes, indeed. Looking at you, Angular 2 through 6.
It's really no different in the React world either. Anything that uses Webpack basically is the same. Same kind of deal. But yeah, so that's the basics anyway of Razor. I'm pretty excited by it. We saw a demo of this. The first time I saw it was in March when we were over at MVP Summit, and everybody there was super excited about it at the time, but it was really, really early then, and they've been releasing on a fairly good cadence now, and it seems like this project has some legs. If we look at the most recent release here, that happened just exactly a month ago, I guess. What's interesting to me, there's lots of really good features that were added, and I'm still kind of digging into these, but what's interesting to me is that most of these features that were added were community contributions. So that's people contributing to the project on GitHub, and like they're not contributing small features, they're contributing like major framework features with this. So it's pretty cool to see, and I think that's a good sign for the project that the community is embracing it that early on already.
Yeah, it's going to be really interesting. Like being able to open up web development to all these other languages. I felt for a long time that we're sort of crippled by JavaScript, that it is not a great language, really. And things like CoffeeScript and TypeScript have filled in some of the gaps, but being able to write in another high-level language is great. And I'm interested to see if there are perhaps some fit-to-purpose languages that are developed for this sort of thing that are even more powerful and even more integrated with the web. Because like C# is great, but it is a general-purpose programming language. So I'm interested to see like what happens if you get something that's a little bit tighter. Like SQL, it's a good example, right? Like I wouldn't want to program in sort of an application SQL, but for fetching data, it doesn't get much simpler than that. Fetching and filtering data.
True. Yeah, and so if Microsoft had approached this as it was just C# running in the browser, it would be a lot less interesting to me. What makes this interesting is that they took Razor and made that run in the browser, right?
Yes.
Because that's the thing that we used to be using on the server side to render HTML, and now we can do that on the client side, and it's kind of a nice language, right? It's a nice way to do things. So
yeah, we're defining some of the boundaries between server side and client side with this sort of stuff.
The one last thing I'll show before we go, because I kind of forgot about this, was that page that we went to where it was rendering a table of temperature data. What it was doing there is actually using HTTP client, so it just injects HTTP client, which is just the usual system.net.http version of HTTP client that we're used to using. It injects that into the page, and then it's able to just get a strongly typed array of things from the server using a URL. So here we don't actually have a server that's, listening to that endpoint and getting data from a database or anything. It's simply a where is this file actually? It should be here somewhere. Sample data, there it is. It's just a JSON file, but what's interesting there is that it's HTTP client. You're not dealing with the usual browser methods of accessing data that way.
But this can't actually be HTTP client under the
covers. So the implementation of that for this version of the runtime is it's probably using fetch, I assume, under the covers.
Yeah, I think it's just something that satisfies the contract of HTTP client but uses browser native methods for doing it. So there's got to be some gaps in there. I can't think of anything right now.
So initially with the first version that they released of that, it was only able to get essentially JSON data. And one of the things that was added for this one is that they can now send and receive binary content data using HTTP client. which is interesting if you wanted to do things like fetch images or fetch you could use a more efficient file format now than JSON.
Oh, that's really interesting. So you could, like, I don't know what the performance of the .NET serializer is in terms of bytes versus JSON, but you could serialize it using .NET serializer and bring it down, deserialize it inside the browser and use it from there. That'd be, wow, that's
Interesting
a bit
for
mind-blowing.
organizations that might have some older endpoints that they're communicating to that traditionally were only available to their their thick client apps.
Mm-hmm.
So you might be able to hit those endpoints now with this. Opens up all kinds of different possibilities that just were really hard to do before.
Yeah.
So I think that's all I had for today, at least for Blazor. There's lots more to talk about, so I look forward to some future episodes on the topic.
Yeah, I hope this is something they continue to develop, even if it's not something that ends up being production ready. It's a really interesting thought experiment, and I think it serves to push the whole concept of WebAssembly forward a little bit. Yeah. All right, well, thanks a lot for taking us through that. And for everybody out there, remember to like, comment, and share down below. And now, because we're on YouTube, I also have to prompt you to subscribe, because that's a thing. So the advantages of those who subscribe, you will receive notifications that new shows have been posted. And James will send you a croissant whenever he has them available. It might be a digital croissant, though. Right. Yeah. So we will see everybody in the next episode of ASP.NET Monsters. Thanks a lot for tuning in.
Bye.